So as a paramedic, if anybody has chest pain, let me know. I'll call 911, which I don't think works in this country. So I haven't actually learned the local emergency number. This presentation is a deliberate fire hose. I have about 3 hours of material that we're going to cover in 30 minutes. And the focus is not for all the little bits and pieces on all of the slides. It's to focus on a few key concepts as we go through, and then you can use the slides as a reference later if you want to go ahead and read them. So obviously the slides will be made available, or you can contact me afterwards. I got involved in cloud very, very early. I've been doing this for about 12 years, and I also have this disaster response background that I was involved with. Nobody cares about that. What is appreciative is sometimes I dress up like a stormtrooper. That's all you need to know about me. And so what we're going to do is we're going to cover two major concepts. We're going to look at leveraging DevSecOps techniques for incident response, and then as well as using cloud-native techniques to improve the incident response process. So this is very much cloud-focused. If you want to go learn about malware analysis, not going to be your talk. If you want to learn how to do incident response using DevOps techniques in cloud and kind of seeing what the future of incident response is, this is absolutely the right talk for that. Now, there's a lot of different definitions of DevOps, because there's not a definition of DevOps. It's kind of a philosophy, it's kind of a culture, but there are some key characteristics within DevOps, and these are things that I can find can dramatically improve our ability to do incident response. And, as background, a lot of this is material we developed. I teach incident response for cloud at Black Hat and with different organizations. I've been kind of involved with this for a long time. And we found that there's some really awesome stuff you can do that's actually much better or more efficient than we've done in traditional on-premise incident response. Now, the key DevOps characteristics are collaboration, communication, automation, observability, and continuous improvement. And you guys have seen this if you do CI/CD pipelines, and if you've built any of this out yourself and you've done software deployments, that's the name of it. Let's put the dev, let's put the ops people together. And we can actually leverage this for incident response in a bunch of the major areas of the incident response process. And so I'm going to break that down from collecting telemetry to detection engineering to threat hunting and the actual response pieces itself. And if we think about the dev side, there's a lot of detection engineering that's basically development. It's a development process to come up with the different detectors and integrate them into our systems, and actually have the automation to look at those and to continuously test those. The operational side is more the monitoring, analysis, detection, the actual detection part, not the engineering part, and the response piece. And so if I break out some of these concepts, there's a bunch of different areas where we can actually take advantage of those DevOps techniques. So for collaboration, you'll see, and again, this is all stuff I'm going to get into, but especially in cloud, and not just cloud, as we're moving more into containers and more of these decentralized operations where individual teams and development teams have a lot more autonomy than they've ever had before. We can't do incident response and manage it completely centrally. It just doesn't work anymore. We don't know what they're running. We don't always have access to the environments. And so moving more into a more collaborative model of incident response using DevOps tools. And I mean technical tools. I don't mean somebody will call having a nice handshake a tool, or knowing how to have people skills. People skills are not tools. Some people are tools, but that's... Anyway, I'm getting a little off topic here, so maybe I should focus. So the collaborative pieces, we're going to work on the right way to do that to actually help improve the incident response process without increasing security exposures. Chat ops is a really powerful way of doing that. We'll talk more about automation, observability, continuous improvement, fast feedback cycles. That's where some of the new detection engineering approaches are coming into play. There's hopefully an open source tool that's being released, let's just say, not out of North America, but somewhere on this continent I can't talk about, that's actually really designed to help streamline processes of detection engineering. So there's really some interesting advances going on there. Now, at the same time, if I'm doing response in cloud, and I've started to throw containers in, if you have a big on-premise Kubernetes deployment, that's kind of like having the fourth cloud. The first, Amazon, Azure, Google, Kubernetes are kind of the four clouds these days, just because of the abstraction, the complexity that's involved. But the things that will change, that's kind of forcing us to actually do some of the things I'm talking about today in incident response are largely because of the impact of cloud and of containers. Things are very ephemeral. Like, how do you do forensics on an instance that was running for about 5 minutes, compromised something else, then was terminated and doesn't exist anymore? And those are the kinds of challenges that we legitimately face when you're doing incident response in a cloud process. Things are more event-driven, more distributed, more decentralized. And then you get into serverless. Like, how do you do security monitoring of Lambda functions or Azure functions? And so we have to have all these different approaches and different sources of telemetry. We can't do everything with EDR and network packet captures anymore because you probably don't have EDR or network packet captures to work with in these environments. And what I want to get across to you today is how to collect the telemetry you're going to need, particularly in these cloud and ephemeral environments, how to build cloud-native threat detectors using the DevOps techniques to improve the process, and then how I really like ChatOps. I think that's one of the coolest parts of all of this is integrating ChatOps as the collaboration tool for not just your team on the incident response process, but utilizing ChatOps to integrate with those other teams. So let's break it out into the individual areas, starting with collecting telemetry. I've done many dozens of cloud assessments, often of very large organizations, government entities, both in North America and over here in Europe. And I find really consistently one of the biggest obstacles IR teams face, if they even know to look for it in cloud, they don't have access to the environments. If I have an AWS organization, I might have hundreds or thousands of Amazon accounts within that organization. A lot of the identity and access management is managed by the team that's building that environment. They're using their own pipelines, infrastructure as code, Terraform, CloudFormation, whatever it is. Me as IR, I may not have read access, and I very likely don't have read and write access to actually do any containment incident response process. And it really becomes critical for you as responders. If you get nothing else out of this entire talk, if you're managing cloud environments, you have to have access to those environments. Now, why does this happen? And why don't we realize it's a problem at first when we're coming from the IR background? Because frequently with incident response, we don't need access to the environment because it's our freaking network, and we have the network packet captures, and we have the SIM log entries. We have all the information we use for our analysis. But with cloud, you can't just run off of that outside telemetry. Any investigation is very likely going to involve going into that environment to get the telemetry because you don't know the resource configurations and other things that you need. So make sure you have access. Make sure you have a central directory of who to contact. I was actually working with a client that I have here in Ireland yesterday, spent the day working with them. And that was one of the big things was documenting in their formal requirements, their control objectives, that they actually build a registry and the information to be in that central registry. And my contact there is like, hey, well, that's hard because this is how we do it today. I go, yeah, but if you see a subscription ID, they're in an Azure environment, in a log entry, how do you know who the business owner and the technical contacts are for that subscription? If you don't know that, you can't respond. Then we want to make sure we get the right telemetry. And with cloud, there's 3 sources, 2 of which are on this slide. The third I'll get to in a little bit. Logs are pretty straightforward. And the main ones we want there are like the activity logs, the API logs of all the API activity going on in that cloud environment. So it's going to be your CloudTrail, your Azure activity log. Logs tend to be saved in files. Files tend to be batch. Batch tends to be delayed. Now remember, cloud, very real time in the nature of the attacks and stuff. And so a lot of what we need to do is understand the speeds and feeds, or feeds and speeds. What information I'm getting, how long is the delay on those particular entries. The logs tend to be very robust, unless you're in Azure, which doesn't give you they don't give you any write activity, so you can't detect reconnaissance in Azure. So don't use Azure. Friends don't let friends use Azure or Oracle. But is Microsoft a sponsor? Okay. That was an uncomfortable laugh. Your uncomfortable laughs make me very uncomfortable on stage. So, yeah. So we got the log files, tend to be relatively complete. What's different in cloud is we have events. Every major cloud provider supports these. And events are fascinating because they tend to be just for specific activities. They can be very robust or they cannot be. Or the line between logs and events may be almost doesn't exist. Maybe every log entry can be an event, which is the way it is actually in Azure. So, events aren't saved unless you tell them to save. And I describe it as the salmon swimming up the river, and you've got the bear sitting there, and the event's the salmon. And the salmon jumps out of the water and back into the water. And if the bear snags it out of the air, he gets to eat it. If the bearer doesn't snag it out of the air, it tends to go away. And this is something we miss a lot because if you're not familiar with these, and sometimes your vendors aren't good at capturing all the ones you want, you don't know to turn on the technologies to be able to capture the events. And the events are often far more interesting than what you're going to get in the log files. Guard Duty, Defender for Cloud, all of those are generating events of security telemetry on top of the actual events of what the users are doing inside of your environments. And so the major feeds we get for these tend to be, and that's just an AWS diagram that I stole, so you have a pretty picture to look at. I didn't write that. But API activity, that's all of the API calls, at least all of the change calls. With some of the providers, Microsoft, you don't get the read activity. And you absolutely, that's going to be your essential telemetry to collect. Then we have resource logs, which is like API gateways and storage accounts, those sorts of things. You selectively tend to turn those on because maybe you don't want to pay to have those on everywhere. You will pay to have those on only in the places you want them. You guys, oh, did I mention you have to pay for every log entry from every provider? Like you don't get it for free? And that's on top of your storage costs wherever you send it. I really should learn to mention those things. Okay. Then the workload logs, like your regular server instance logs, you're going to need to collect those kinds of things. Then there's other things I'm just lumping in as service and diagnostic logs, depending on the platform. VPC flow logs or VNet flow logs. Those are network connectivity logs. It's kind of like NetFlow that you're going to get, but you have to turn that on. If you don't turn it on, you don't get it. And all these different cloud services all have different logs. It is complex. I have spreadsheets that are this big. Don't know how a digital thing can be that big, but it's this big of all the different sources, where you can collect it. Is it a log or an event? If it's a log file, where is it saved? Because there's like 4 or 5 different places typically in each cloud provider those can be saved. And I'm not saying that this is overly complex. Think of all the stuff we do traditional on-premise. It's just that if you've done this in a data center, you know where all of this stuff is already. So it's just a matter of upping your skills to know where those are in cloud, as well as understanding the speeds part of the feeds and speeds. When I'm doing my design of my security telemetry for cloud, I tend to break it up into 2 kind of major pathways. Sometimes there's a third pathway. One is the fast path. Fast path has 2 tiers in the fast path. For example, the way I have my stuff set up, I cheat because I use my own product for these pieces, but the way we have that set up, I will see in less than 30 seconds almost any piece of activity in an account. And so I'll get the alert. So that's the fast path. We're using CloudWatch events from CloudTrail, and then we push those events onto an event bus, and then I can do my rules and forward it on to my analysis system from there. If it's not going to be within a few seconds, you're probably going to be able to get a lot of stuff within 15 minutes. Why 15 minutes? Because the default for batching tends to be about 5 minutes if it's going to be a file-based log, and then that batch file gets saved down. So you're probably going to be somewhere in that 5 to 15 minute range to see that activity. So that's that fast path side. Now the slow path is if it's saved into those files and it's batched, and then it has to go to a collector or forwarder. So slow path is like most of the stuff you're sending to Splunk. You're probably not going to see it for like an hour, depending on how you have Splunk configured. You can tune that down to like 15 minutes. Now, why make a big deal out of this? If you have an active attacker in your environment, do you want to be a few seconds behind their activity, a few minutes behind their activity, or an hour behind what they're doing? And I have gone into environments where people have configured things in ways, and mostly these are places where they send stuff back onto their on-prem SIEM. And frequently it's Splunk, but it could be anything else. That's not a problem with Splunk. But the way they have it all configured is they won't see the actual activity for up to an hour after it occurs. And even some of the cloud provider logs, there's some in Azure, for example, that it's an hour delivery time, and others you get things in a few seconds. Amazon, a bunch of stuff hits at 20 minutes. Like Guard Duty, most of the Guard Duty stuff is on about a 20-minute delay. So for me as the responder, figuring out what I need to do, I need to have an intimate understanding of what is I collecting and how fast am I getting that information. We also have to watch out about storage volume, and this is blown apart. This is particularly a problem if you throw a bunch of stuff on premise. It's less of a problem if you keep it in cloud and you understand your cloud storage. But if you take, I have a friend in an organization that has 16,000 Amazon accounts. 16,000 AWS accounts. They have to collect security telemetry from all of those. Imagine if you have to collect all of that into a single location, how that's going to blow out your storage cost and your ability to store all of those. So we do tend to sometimes follow this collection architecture of, I call it kind of a filtering and forwarding, where some stuff is set local, and then you stage out and you push the filtered results out for the things that matter for security. So for example, when I'm running training classes, a lot of times I'll teach people, keep all your raw logs in that account, or in that environment. Then you can build alerts, and you can send the alerts out, or a subsection, a filtered version of those events. We had this once. I was working with an org. They were hitting us with a massive stream of data, and it actually, we had a really scalable system, but it still started pushing stuff on the edges because it was such a sudden jump. And they had turned on these this particular kind of KMS event that was actually flooding the event bus and the API endpoints where we were collecting that data from. And then all we had to do is change the rule, because those events were not of security significance, the ones that were being sent over. And we got the security significant ones where they needed to be. Those raw events were still available locally. So there's nothing wrong with using a distributed architecture, and that's why I call it that cascading, that filter and then forward, filter and then forward to the next step. And you're already doing this, even if you don't know it. If you're using somebody I worked with, they had Bit9 Carbon Black. They kept all of it in that system, but as that developed alerts that required investigation, those alerts were what got forward to the SIM. So this is nothing different. It's just we haven't used those kinds of technologies before. And I'm going to just blast through this. Providers all have a bunch of essential feeds. I will provide the slides. I'm only still talking about this because I saw somebody pick up their phone to take a picture of it. And the providers don't always have overlapping stuff. Microsoft has a SIM, Sentinel. I've heard it's pretty decent, just a little pricey. Google's got Chronicle. Google now has, Mandiant and all sorts of stuff that's in there. Amazon doesn't have a SIM. They all have some kind of cloud security posture management. They all have some kind of DLP. And so again, know the environment that you're working in to figure out those tools. Now, when we're actually, and this is almost to the last of the collecting the telemetry piece, the way I like to think about it in my head, just to organize these, there's operational feeds, which is the what are people doing? And then there's the security tool feeds, which is the security tools the cloud providers give you. I'm not even talking about your third-party tooling. And so for the operational feeds, it's like the API activity, it's the service logs, the resource logs, diagnostic logs. Those all matter for security. Most of them matter for security, especially depending on the environment. We need to know about them. We need to collect them. We need to be able to forward those things on appropriately. And these are just some examples on, AWS, because that's where I tend to do most of my work. Then we have security feeds, though. Guard duty alerts. Guard duty is Amazon's like IDS. If it sends me an alert, well, that's something I probably need to pay more attention to than just the regular old API calls. I have Security Hub, which is a posture checks for misconfigurations like public S3 buckets. So every single cloud provider supports these. You're going to have your operational side of things. You're going to have your security side of things. How do I tie it all together, and how do I collect all of this stuff in the first place? There's no one right answer. I have my biased preferences based on how I like to work in environments, but then I still will go in some place, maybe they have to do it a different way than the way that I normally like to do it. But again, it comes down to this cascade and filter pattern where I have everything, all the key telemetry turned on within an account, a subscription, a project. Different providers use different terminology for this. The events I will typically feed to a cloud detection and response tool. Now, if you don't have one of those, you feed it to your SIM. The events are the guard duty alerts. It's the real time. It's the less than 15 minutes and usually less than 15 seconds feeds. Defender for Cloud, those are all examples of the event-based feed systems that you want to push out. Raw logs, you're still going to collect those and probably send them to a SIM or something equivalent there. There's also going to be your cloud security posture management, which is the tooling that detects, oh, you have public S3 buckets, or this IAM is misconfigured, or this port 22 is open on this instance. So you're going to have that piece as well. You're going to forward that into whatever you're using for your detection and response tooling. For some of you don't have that, you're just going to run everything out of the SIM. And then you can, depending on the environment, you can do the alerting from the cloud native, the cloud detection response, and then send those alerts in your SIM. If you're SOC analyst or used to running stuff out of, Splunk or Sumo or whatever they're using, Or you can also go the other way. What SIMs are really good for is the low and slow attacks, the read activity reconnaissance, except on Azure, because you can't. But gathering that, not that I have if anybody in Microsoft can fix that, just let me know. I'm here for you. But you might send the SIM alerts through the other way. So there's a bunch of different ways to kind of architect this. Get those alerts central. And then if you need to, you can dive into these environments to do your deeper investigation. So that first part is just to really tell you, how do I collect this? Give you a sense that it's going to be different in cloud. There's some newer architectural approaches that you can take to do this. You can use a lot of your existing tooling. I will tell you, you're probably going to want to start looking at more of like a cloud SIM of some sort. I'm not selling it. I don't sell a cloud SIM. Like, I just trying to send all of this to your on-premise SIM. Get your cloud SIM from the same vendor. I don't care. But trying to send this all into your data center, the only one that's going to be really happy is whoever's selling you your hard drives. Now, in detection engineering, it's a little bit different because now we are looking at the management plane. We have these widely varying deployment environments, and we have the feeds from the cloud service providers that need to be integrated. This really hammered home. I needed to write this slide and have this section of a talk when I was working with an org, that their detection engineers were just taking standard IOCs like IP addresses and such and looking for those in CloudTrail logs for their AWS environment. But they were missing all the cloud native kinds of events that mattered. Now, with detection engineering, there's two aspects of this. I've been kind of talking a lot about integrating cloud in, but now we're going to get into some of the DevOps techniques that we can integrate. Because I think of detection engineering in these environments as a DevOps process. I think of it as a development process. I want to use CI/CD pipelines to create my detectors and push those out. Now, why does this matter? I may have to push these out in a much more distributed, decentralized architecture than I ever have before. You're not going to run around and manually do these. You're not going to import them from spreadsheets, and you're not going to get all the ones you need from your vendors. So you're going to have your own internal detection engineering process. Other things like, do I want to run every detection in a development environment? Probably not. Do I want to run everyone in a production environment? Probably, or maybe it's going to be different between the two. So I'm going to think about using templates and CI/CD pipelines and tagging for the appropriate environments. Also, when I get information from feeds, I got one today. I wish I could show you on my laptop. I had to log in with my root account to do something in one of my Amazon accounts, and it's a blob of JSON. Like, I can read it, but it's not nice. And what if I could enrich that and make it more human readable and add data like, well, what environment is that? How is that thing tagged? What data is in there? Those are the kinds of things that you can actually start building into your detectors. And holy crap, I picked the wrong colors to try and read the slide from myself down here. So if I think about it on the dev side of detection engineering, so in the middle there, in the planning page, research and intel. And there are some sources. I'll show you a few of those before we get there. There's some new detection communities that are out there, have been developed for cloud to get the info about what I need to do. Then we have to define that, and that's going to be in a template, ideally in kind of an infrastructure as code. Sigma's not really meant for cloud, but something Sigma-like. Maybe you have to do it yourself today. I do know there's some more industry standard-ish things being developed. They're not out there yet, so I can't give you the references to those. But if I were going to start this today and I didn't have anything else, I'd look at like MITRE ATT&CK for cloud, and I would look at converting those things into Sigma rules. That's what we're talking about here. Then you have to code them up. So is there going to be a Splunk query? Is there going to be a native query in a different kind of tool? How are you actually going to do that detection itself? Then you want to test and simulate that. So we're seeing an emergence of more simulation tooling that you can actually simulate. And the easiest way to simulate is do an attack yourself, record those events, replay the events. So you're actually able to test your detections work. Because cloud is so different and distributed and fragile, you're going to want to get to the point where you can automate some of this fault injection across your environments, because you may lose feeds. Because if you don't get any guard duty alerts for 5 years, does that mean you weren't attacked? Or does that mean that got turned off and nobody noticed? So you're going to want to have a way of validating that you're still being able to get that information. Tune it over time, provide feedback, and then enrich that data when you do it operationally. And those detections you're going to pull from 3 places. 2 we've talked about, the logs and the alerts. That's pretty clear. The third one, though, gets more interesting, and that's the actual configuration itself. And I call this Schrödinger's misconfigurations. If you find out that somebody made an S3 bucket or a storage account public, is that an attack? Is that a misconfiguration? Or was that meant to be done and they just forgot to ask for their exemption from the policy? You don't know until you look. And this is why access to these environments becomes so absolutely critical. And you don't even know when you look based on who made the change, because the single largest source of cloud breaches today is exposed credentials. And it could be service account credentials, it could be developer credentials, admin credentials. So if exposed credentials, impersonation of the user, is the biggest vector of attack, then I find a misconfiguration. But I don't know if they meant to do that because it's a decentralized environment that they manage themselves. So this is the first critical stage of this. And this is why, to me, I want those misconfigurations. Like normally, you don't take your vulnerability assessment results and use those to trigger an incident response process. And a lot of us think of cloud security posture management tools as like a vulnerability assessment tool. Do I have an exposed misconfiguration? But when that misconfiguration happens at the point in time, that very much could be the indicator of an attack. A public snapshot is an exfiltration technique used by multiple attack groups today. Was that a public snapshot meant to be there, or was that an attacker being there? And so that's why that's really, really important. So what are some of the things when I'm looking at those misconfigurations that give me a higher index of suspicion? What's the source IP? Was there any reconnaissance? What's the environment? Is it a production environment and like that should never be public? Or was it a development environment where developers doing it just to exchange data between accounts and they were too lazy to get the two account IDs to do it differently? And really, the best way to do this is going to be ChatOps, and we're going to get back to that in just a moment. So when I'm looking through these log files, when I simulate attacks for my students in training classes, a lot of it is I'll show them the same attack coming from a trusted IP address and from a non-trusted IP address. We'll fully simulate that just to give them different indexes of suspicion around things. A lot of different places that you can detect. You can do it in the SIM. You can get detection straight from your cloud providers, Defender for Cloud, Amazon GuardDuty. Your cloud security posture management may do some detections. That's how you're going to get your misconfigurations. And then there's this newer category of cloud detection and response tools. There's CDR tools, EDR tools, MDR tools, XDR tools. I don't know if anybody has any other letters they want to put in front of DR, let me know and I'll go patent that. Make a lot of money, probably. So these are some examples. This is a CIS benchmarks, Center for Internet Security benchmarks for AWS. It's a pretty good list. They've got a similar list as well for the other providers. Here's some examples of indicators of compromise. Things like get caller identity, which is an API call in AWS that says, tell me who I am. How often would a service account try and find out its own identity? Probably not too often. Higher index of suspicion. Sharing between accounts that I don't know about. Making something public. These are all IOCs. The problem is they can be difficult to capture all of these activity if you don't know what to look for. So this is where the research intel piece comes in. And again, we're starting to get more of this being in public. When I first started talking about these, I had to kind of make all my own up because I've been doing it for 12 years. But now there's some different areas in the cloud security community. Some people are starting to share more of these more. So what are your recommendations? Your old IOCs don't go away. Some of those do still matter. It's going to increase your index of suspicion. I focus on the management plane. I call it cloud log before syslog for these attacks. I go into orgs. They care more about the network side of things because that's how they built up. They're going to look for their MDR stuff, or EDR stuff, sorry. That's how they're used to looking at their endpoint and their network. I'm a cloud guy. I don't give a fuck about endpoints and networks. All right? Those are highly disposable. It's like, I have 3 kids, so I have a spare. I'll have 3 VPCs, so I have a spare. Who gives a shit? And, sorry, I promised Brian I would curse on stage. So, I just had to do that. Yeah. No, I'm going to blame you. Yeah. So, your normal IOCs will still work, but those come later. Focus on these more native IOCs, starting with things like identity and access management. All cloud security failures are IAM failures. All IAM failures are governance failures. So look at different kinds of IAM activity and privilege escalations and new account creation, new credentials created, things sharing between accounts, things becoming public. It's really not much more than this list on this page. It's not overly complicated. And I kind of talked about all of that already on the previous slide. I also really am a fan of canaries. Thinks Canary does a really good job with AWS stuff because if exposed credentials are the number one source of cloud breaches, why not just expose a whole bunch of credentials that don't matter and instrument off of those? And if I know where I seeded them in my environment, then that can direct me to the compromised environment, because a regular employee shouldn't be trying to use those. And if a regular employee does try and use those, then you terminate your employee. That means fire, not like terminate. Okay. The link on the bottom is from the guy actually do the incident response training class with Will Bankston. He ran a bunch of cloud security at Netflix. He runs it over at HashiCorp now. I think he's the number 2 guy for security at HashiCorp. He has a really cool automation technique for handling that. Then, as I mentioned, you want to have labs. You want to be able to simulate these, push these into different environments, and you can use your CI/CD pipelines for that. The last part of this is, and I'm going to... Again, 3 hours and 30 minutes, and I'm now at 31 minutes, I believe. So I got to finish up. Distributed response. You have an attack. You detect it. You're going to enrich that data through your automation platforms, and eventually all of it's going to get routed to a SOC analyst. That analyst isn't going to have any fucking idea if that matters or not, unless it's a really obvious alert, like a change for something becoming public. Well, this guy at Slack, Ryan Huber, who's now off doing other things now, he was the first person I knew to do this. When he got these alerts, he would just automatically Slack them to the person associated with those credentials and said, "Did you mean to do this?" Out of band. And if they said yes, the issue was closed. Unless it was something that was a huge policy violation. Just that aspect of communicating with the people responsible for that environment will let us know if that's something that matters or not. And we can do that in ways we never could before. They're in chat ops, we're in chat ops. We're all using Slack or Teams or something else. So send that message over and have them and you see it at the same time. Security and that team. And you get instant collaboration. You're not sending emails and spreadsheets or getting somebody's attention. It drops into the same feed their team is using all day, every day, as it is. And you can even tie in automations. There's some tooling to do this. This is not new or well, it's new, but it's not magic. Like AWS has their chatbot stuff, and there's a bunch of vendors and stuff coming out that have this already or are coming out with these kinds of things. That integration, that collaboration, breaking down the silos can really help us as incident responders to figure out what's going on. I don't really have time to go through the threat hunting stuff, just some pain points. These are some of the technical things. The fact that the cloud providers can often be bad. Like if I want to do a search on a resource, I have to look in 3 different places in CloudTrail logs, and the one named resource is probably the wrong one because it's almost never populated. You have to look at the API request and the API response. And then Azure's got a completely different structure for their doing it. But what's going to help me with all of this, going back to what I've talked about, using the tooling, collecting it, automatically enriching it. Imagine seeing the information about a resource when you get the alert tied to that resource. These are all just API calls away. I've seen products do this. I've seen people code it themselves. This is the future for working inside of these environments. So we have all this metadata that we can access. Just throw it in front of me. Don't make me go out and look for it. I don't have to go do, forensics the same way I used to do forensics, at least for the cloud management plane stuff, which is what this is heavily focused on. And then have your runbooks automated, have the queries built, have the code built to automatically do all the scans and everything else. And this is, really common. Will, the guy that works over at HashiCorp, anytime they have a new instance, somebody has to write a runbook and they have to pre-build the queries for the next analyst, SOC analyst, that's going to go through and manage that. So if I look at the overall maturity of the process, the more I can become automated, the more I can become policy-based, and the more I can take advantage of this collaboration, of CI/CD pipelines, of writing things more as code, pushing them out, and having the consistency in process, the better my life is going to be when doing IR in these kind of newer and more distributed, decentralized. And to be honest, these are alien technologies for many of us. It was an alien technology for me for the first 3 of the 12 years I've spent working with it. That's it. Thank you for your time.